A very good evening and welcome to the broncolor studio here in Switzerland. I'm Urs Recho, and this evening I have the pleasure to talk to you about the two flagship power packs of broncolor, which is on my right side the Scoro, well known for many, many years, and introduced about a couple of months ago, half a year ago maybe, the Satos power pack. Today's webinar is a product insight. However, I will not discuss the most hidden, most detail, and I will focus on the main differences of the two power packs. Some of the features are misunderstood, as we detected in the last couple of weeks and months, so I will try to make more clear what is actually the differences between these two packs. This all is going to happen with the help of a PowerPoint presentation, and we will talk about the three parts of this presentation, which is the basics. Second, I will pick out some technical data and features, and in a last part, we will discuss some special functions of the two packs and compare them. After each of these three parts, and of course at the very end of today's webinar, you have the possibility to ask questions. All the questions you can write down on the right side of your window. There's a chat window, a chat section, so type in your question there. I have a dear colleague here in the studio with me. He will field these questions. He will answer some of the questions directly. He will write down some of the questions that will be answered later on by support@broncolor.swiss, and some of the questions he will pass on to me that I will discuss and answer here live. Right, so this happens after each part and at the very end of today's webinar. So let's get started right away. So I said we start with the basics, and of course the power is probably the most important feature or parameter of a power pack. Both power packs, the Scoro that you see here with the picture on the right side and the Satos on the left side, they have a max power of 3,200 joules or 1,600 joules, the smaller version. So the max power is identical. However, we already have a first difference if we look at the minimum power. There with the Scoro, we can go down 10 f-stops from 3,200 to 3 joules, or with the 1,600 joule, we can as well go down to 3 joule. So with both power packs on the Scoro, we have the same max, we have a different max power, 1,600 or 3,200, but the minimum power is the same. It's always like the 3 joules. However, on the Satos pack, we go 1 f-stop lower. So we have a lower minimum power. Why is this? I mean, when I'm shooting for many years, and in the earlier years in my career, I was shooting, let's say, advertising 4x5 at least medium format. And I was very happy to have a lot of light, to get my still life 4x5 or 8x10 really sharp. So the more power I had, the happier I was, or the less problems I had. But nowadays we have all the beautiful small cameras with the beautiful lenses that you can open to 2.0 or 1.4. We have increased sensitivity that is more or less noise-free, so we can work with much less light. And if I want to do this in the studio, it's important that I can go down with the power as well with my light settings. So like in this situation, you see the full portrait on the left side, you see a very narrow cropping on the right side, and you see the super selective focus of this portrait. So I have the full sharpness on the iris of the model, and then already the eyelashes or even the eyebrows are far out of focus. So if you are in this kind of photography, beauty photography, or even still life photography, and you would like to have this super selective depth of field, so do not only have a look at the max power of the power packs or of your general light equipment, but as well, how low can you go? All right. So we have the minimum power is already quite important difference, and this has some consequences. On the Scoro, we have a power range of 10 f-stops, and on Satos, we have a power range of 11 f-stops. On all power packs and compact units before Satos, we always had a full power of 10. So no matter if we talk about the Ceros 400 joules full power corresponded to power setting 10, a Scoro 3200 as well, full power means 10. On the Scoro, as you can see, if we go down from full power 10, if you go down the full 10 f-stops, we end up on a power level 0. Doesn't really make a lot of sense in our eyes because 0 sounds like no light. So that's why on the Scoro, we only go down to power setting 0.1 because we didn't want to indicate a power of 0 because this sounds like switched off. The problem is now, with the Satos, we have not 10 f-stops of power range, but 11. So where shall we put the 11th f-stop? Shall we give you a power of -1? And doesn't really work because a power of -1, it's actually my big dream as a photographer in the studio, it would be negative light. Like when I take the airplane, I put on my noise cancelling headphones to avoid all the noise. So in the studio, I would like, of course, to have negative light to increase the contrast. So let's say some light here and some negative light on the other side to increase the contrast, but unfortunately, this doesn't work. So a power setting of -1 doesn't really make a lot of sense. So that's why we defined something new. We defined 400 joules equals power 10. On the Scoro, we still had to calculate +/-1, which means on the big Scoro, power setting 8 would be on the small one a 9. That we have joule-wise the same. On the Satos, it's a different story. 9 is always 9. 3 is always 3. So this +/-1 is no longer needed to calculate because we have this kind of bridge at 400 joules, which means 400 joules is 10, 11 would be 800 joules, 12 would be 1600 joules. So power setting 12 is the max power of a Satos 1600, and power setting 13 is the max power setting on a Satos 3200. So the power range over the 11 f-stops on a large Satos goes from 13, 11 f-stops down to 2. Right. Let's check out the master, because there we have some very nice new features integrated in the new pack. For this, I would like to give you here an overview over the two packs. We have here on my left, we have the Satos 1600, and we compare it with the Scoro as well, 1600. And later on, we will use as well a Pulso L lamphead, which is ready here. Now, on a Scoro, I have chosen here on channel 2, I have chosen power 3. On channel 1 I have chosen power 6. Together, 3.6 does not equal to 9, but it equals to 6.2. Quick explanation about this. So let's say if I have 6 plus 6. So if I add these two lights, it's just double the light. 6 plus 6 is 2 times 6. So this means I have double the light. I have one more f-stop. So 6 plus 6 is 7. Right? So this is how these numbers work. Let's go back to this. So we have 6 plus 3 is 6.2. And now I would like to zoom in a little bit on the Satos to give you a closer look at the master power indication here on Satos. For this, I have to move a little bit my camera. Try to go a little bit further down, which is still possible. And I move this into position, right, something like that. Okay, good. So let me tell the camera where to focus on. I want to sharp it here. Okay, good. So again, 6 plus 3 is here 6.2, as seen as well on the Scoro. But now a very cool feature is here this indication, this blue bar. the blue bar actually indicates the asymmetry I'm working with my current setting. So if I go down here with the power 6, obviously the asymmetry becomes less, and this bar here becomes more narrow. So in this situation, we have 3 plus 3 equals 4. No asymmetry, just some asymmetry between one outlet and the total power. This becomes very important if I work with a large asymmetry, something like this. Now you can see the size of this bar kind of defines the amount of asymmetry I have. And the larger the asymmetry, the less I can move this bar around between full power 12 and minimum power 2. This, of course, is a very important indication, because if I have a large asymmetry and I change this, I always want to keep the asymmetry, the power difference between the two outlets. I want to keep them constant. That if one of the two, let's say if I go up with the power and the upper power reaches the max, I don't want to follow up with the lower power. Otherwise, I change my asymmetry and I change the light characteristics. So that's why we have on the master switch or on the master indication, we have this indication about asymmetry, and it instantly tells you how much you can move the power setting up or down and still work with the same asymmetry. So this is a really cool feature. I will later on show how you actually can change, the master power. On the Scoro, we have the master power switch. On the Satos, it works slightly different. Right, okay, so this is about the power settings. Asymmetry, as mentioned before, asymmetry is as well something very, very important. And amazingly, both packs, and this is really a feature that you should not underestimate, both packs offer the entire power range as asymmetry. So imagine here, even on the Scoros, we have from 3000 joules, even more, down to 3 joules, we have a factor of 1000 power-wise between the two flashes, and we can actually fire this. Here we have even a higher asymmetry regarding the power. So we have from 3200 joules down to 1.5 joules, and we can use the entire power range as asymmetry. However, there's one big difference between the packs. And the big difference is if we talk about color-corrected asymmetry. On the Scoro, we have 3 stops are color-corrected, and on the Satos, the full power range is not only available as very precise asymmetry, but it's additionally color-corrected, and that's really an absolutely crazy feature that this is technically even possible. Okay, quick explanation why this works like this. On the Scoro, if we work with asymmetry, with large asymmetry, the voltage of actually the light is more or less the same, and we achieve asymmetry by cutting flashes earlier or later. And this means if we cut earlier and earlier and earlier, we cut off some of the red light at the end of the flash discharging curve, which means there's more blue light remaining in the flash curve. That's why if you have a large asymmetry, the lower power will turn slightly bluish. Okay, good. So where are we? So we have this, absolutely freedom to work with any asymmetry, absolutely color corrected over the entire power range on our Satos power packs. Obvious difference is we have no batteries on the Scoros, and yes, we do have batteries with the Satos. The recommended configurations is 11 and 20 on the Satos 1600. What does this mean? The first number indicates the amount of batteries, and the second is the amount of power supply units. So when I work normally in the studio, I have electricity from the grid nearby. So I connect, actually my Satos is connected to mains. I still use one of the battery. Within brackets, if I use batteries, the more batteries I use, the faster the pack recycles, by the way. But of course, if I have a power supply unit integrated, I have constant power to feed my modeling lights, as well to recharge my capacitors, and the batteries are not drained. The batteries do not become empty. Okay, so this is the recommended configuration in the studio. This 1-1 and the 2-0, of course, 2 batteries, 0 power supply units when I go on location, when I go outside. On the large Satos, the 3200, theoretically, we have more options. We could have, let's say, only 1 power supply unit and 3 batteries. However, here as well, the straightforward configurations that are recommended by us is a 2-2, 2 power supply units, 2 batteries, or a 4-0 if you go far away from electricity grids. And there you have a lot of flashes. We will see this right away. And you will have, in fact, the shortest recycling times when you work with batteries only. Talk about batteries, regardless of the power pack, when your batteries, I'm talking here about the 2-0 or the 4-0 configuration, you have 240 flashes at full power, okay? We have the same amount of flashes from the small power pack, 1600, and the 3200. Because on the 3200 we have twice the power, but we have as well 4 batteries. On the 1600 we have 1 f-stop less, but only half the batteries. So when they're fully charged, you can calculate with about 240 flashes at full power. It's more or less linear if you go down with the power. So if you work on 1 f-stop less, let's say on the 1600, this would not be 12, but 11, power setting 11, 800 joules. This means that we have 2 times 240, so we have close to 500 flashes of 800 joules from the Satos 1600. So it's more or less linear as explained. Good. And one more word about the battery and modeling light, or battery and continuous light mode, because we will see that the Satos is not only flash equipment, but it is as well very advanced continuous light equipment. And there I would like to make a comparison between the power or the energy consumption of continuous light versus the energy consumption of flashlight. So let's say we have 2 modeling lights. Of course, we can connect 3 lights, but let's say we have 2 of 90 watts each, which is the max power consumption of the LEDs in the Pulsar L anyway. So let's say we have 2 of them. So we have 180 watts for the 2 lights. And let's say we leave these lights on as modeling light or as continuous light during about 10 seconds. So we have 10 seconds times 180 watts. This is nothing else than 1,800 watt seconds. Now, watt seconds and joules is exactly the same. The physically correct expression is joules, but in many countries watt seconds is used. So this means that 10 seconds of full modeling light, two modeling lights, full power, costs you more than 1600 joules. So you lose per every 10 seconds of 2 modeling lights or 2 continuous light timing on, you lose every 10 seconds, you lose 1 flash at full power. Okay, so that's actually quite a lot. So this means that if ever you're working with batteries only, I'm not talking about the situation where you have it connected to the mains in the studio, but if you're working from battery only, make sure that if you do not need the modeling light, switch them off, because you save many, many flashes like this. The handling. Of course, on the Scoro on the right side, you all know how it works. Physical buttons, super straightforward. And we have many more options on the Satos. We have a touch display. We have physical buttons or any combination of this. And last but not least, or even on top of it, we have bidirectional communication between the lamp head and the power pack. and we have a super flat menu. So in the handling, there is really a big improvement. It's much more self-explaining, much more intuitive than even, let's say, the already very simple Scoro, which has a scroll down menu, but the flat menu, we will see this later on the on the Satos, is really super easy to understand. Let's have a look at this quickly here in the with the live camera. I reposition this quickly, going up, move over here, and bring things back in position. Right. Okay, good. So we have seen it a little bit before already. So I can press here on the touch. If I press this just very quickly, of course, like you're used to it from the Scoro or from other units, it just increases or decreases the power by 1/10 of an f-stop. If I stay with my finger longer on it, it makes full f-stop jumps until I take my finger away here at minimum power 2.0, or I can go up again. Okay, so this is option 1. This is, of course, I like it. It works perfectly. It's super straightforward. I don't have to activate any channels. I just press buttons and it does exactly what I want it to do. But if you're not, let's say, too much into touch screens, you don't have to use the touch screen. You can go a different way and you can choose the channel. So let's say with this physical button here, I choose the channel. And now I would like to show quickly how this looks like. For this, I have to make the camera a lot darker. So when I choose here the channel, you know, when the channel is not active, the power indication is white. When I choose the channel, it turns blue. It's a little tricky to show this on the video. I hope you get a certain idea how this works. And now only this channel is chosen, and I can use here the knob to change the power. Okay, very straightforward. So designing these the knobs and the possibilities to change the power, to manipulate or to navigate in the menu, we tried to make this as intuitive as possible. So whatever you think, I think it works like this. Maybe I can do it like this. Everything works. Any touch solution or combination of physical buttons and touch. There's not only one way to do it. You can configure any manipulation. Everything that you think it works will work and do exactly what you want the pack to do. We can as well, let's say, define 2 channels. So now they are both inactive. So I can choose this one, and if I use here the main switch, of course, this changes now the power of the 2 outlets. Last but not least, I can simply start turning here, and then I have this focus frame moving around. So I can bring this focus frame over the power 2.1. I pressed it, and then I change it again, press it again, move on, go over here to 5.1, press, take this power down, press again. So this is, in the end, just with one knob, like you have it in, not in my car, but in modern cars. It's just maybe a one knob navigation all around. So as I said, touch, combination of touch and physical button, only the physical button, and so on. So everything you want just works great. Last but not least, we have here as well the main power, the master in a way. Here on the Scoro, we have one more additional power up and power down, which is the master. So if I go up with the power here, the asymmetry remains the same. If I go down here, okay, this is well known. So asymmetry is changed here. The total power is changed here. The master indicated with the white number, the individual power or the asymmetry indicated with the blue numbers. Here we don't have this 6.2 is not indicated that big or that important, but it's here as well. Let's say we have seen this later on before. So here we have the power indication of 8.9, and as I said before, the size of this bar indicates the symmetry. but I can choose now here as well the master. So I don't have to choose. I can just go for the master, and now obviously all the channels are chosen, and I adjust the power like that. If I would like to choose all the channels except number 1, I can deselect it as well. Now only channel 2 is still blue, which means only there I change the power. So like every new equipment, you just have to dive into it, but I'm absolutely sure after 15 minutes, half an hour, you're super familiar with it. And as I said before, everything you try, it will just do whatever you want it to do. It's super intuitive, super easy to handle. Last but not least is the menu. Yep, you can see it. I can go a little brighter now again. That's the other direction. Okay, while on the Scoro, we can go into the menu, and then we just have a very simple scroll down menu. As well, no hidden functions, but some of the functions maybe end up on position 17 or something like this, so I have to dial down quite a long time. We change this here, and the entire architecture of the menu is super flat, so there's nothing behind it. With one exception, maybe more, there are more functions hidden behind the more function, okay? But besides this, we have alternate, delay, sequence, flash setting, sync, studio setup, and so on and so on. Everything you see it. As soon as you press here the button, bam, direct access to all the functions. Super easy, super fast. Let's say if you work with assistants, they just have to press one button and they don't have to scroll down and look for any special functions. They press one button and bam, all the settings, the direct access to all the settings is there. I mean, you're probably working as well with different camera once in a while, and whenever you change, I don't know, from a Canon to a Sony to a Nikon to a Fuji, it's a nightmare to navigate in the new menus. Okay, here it's super straightforward because it's the flattest possible architecture of the menu and direct access to everything you will ever need. So very comfortable. Right, okay. I forgot this already in the morning. I forgot it now again. There is one more very cool feature, and this is the bidirectional communication. So let's say we have quite a complex setup. Here, this power 8.3, which is indicated on the lamphead, which is a pulsar L in this situation, of course, corresponds to this 8.3 over here. So if I change the power here on my power pack, obviously, it's communicated right away, almost right away, over here, so 8.0. But now, very cool, is if I would like to change the power on this light, I don't have to follow the cable and say, okay, this light goes under the table, comes round in the other corner, and it's here the 8. No, I go directly to the light. I choose, again, I have the same navigation like before. So I take the focus frame around the power setting 8, press the button, it's blue. I change here the power from 8 to 9, and instantly it's communicated back to the power pack. Okay, so no long following the cables. I would like to change this one. So where does it go? No, you walk directly to the lamphead, jack, you change the power, and instantly the power pack follows. So super convenient. Right, okay. Now I think I didn't forget anything. No. So this is already end of the first part, the basics, talking about the power maximum, power minimum, power asymmetry, and handling the navigation in the system. Are there any questions about this part already? No, I don't see anything. My colleague shakes the head as well. So this means that everything is absolutely clear, which means second part, technical data and features. There, of course, I could get completely lost and talk about all the technical data. However, I just want to pick out a few focus points. The first, one of the biggest or the most important parameters, of course, when talking about flash equipment is the short flash durations. On the Scoro, we reach a 10,000th of a second flash duration, and now on the Satos, we even reach a 29,000th of a second. I would just like to bring this a little bit in relation with what we are normally used to. On most of our cameras, there are some new fancy cameras just coming out lately that are faster than the 8,000th of a second, but most of our cameras, including everything I have here in the studio, the shortest exposure time, which is with the camera identical to the shutter speed, is 8,000th of a second. So even the Scoro is already shorter than the shortest shutter speed on your cameras. And now if you divide this even by a factor 3, you go from a 10,000 to almost a 30,000th of a second. Really, I couldn't think about any movement that's not frozen with such a short flash duration. Okay, so that's really an absolute crazy setting. Maybe if you shoot or if you try to capture a bullet leaving a gun, maybe this movement is still too fast, even for a 30,000th of a second. But everything which is, let's say, water splashes, wind in hair, dancers jumping around, breaking glasses, and so on and so on. With a 10,000th of a second, you get very, very far already. And if you divide this time even by a factor 3, we are close to a 30,000th of a second. And there I really have to think quite a long time until I can figure out a movement that still shows some movement with this unbelievable short exposure time. Because the flash duration in the end, the flash duration is the exposure time. It's not the shutter speed on the camera. This is a misunderstanding that I see many, many times in the studio, that let's say you shoot a portrait with wind in the hair, and on the camera you use a 60th of a second shutter speed, but this is not relevant as long as the ambient light has no effect on the photograph, and the super short flash is actually responsible for freezing the movement. So the exposure time comes from the flash and not from the camera. Shutter speed is not the same like exposure time in studio flash photography. Good, so we discussed these values, a little bit of technical talk. How do we achieve this? And it will be very important if we talk about the different technical feature later on. For this, we have to have a look at the different discharging curves. On the right side, again, we start with the Scoro. The orange line is the amount of light that leaves the flash tube, so we have a peak. And then after the first fancy peak, the flash drops down lower in intensity and as well not constant in color, because the first peak is a very high intensity light. The flash tube heats up like crazy. So at the beginning of the flash, we have rather cooler light, a more bluish light. Then it drops down, passes kind of like a neutral area, and then shifts into red a little bit. Of course, important is the average of the light. And this, of course, even with a Scoro, this is 100% neutral. But the light is not constant. And on the Satos, we have a different line. It's not 100% rectangular, but it's much closer to a rectangular light output, which means we do not have a dramatic drop of the power during the flash discharge. So we cut a little bit the fancy peak at the beginning and kind of use this energy at the end. So we are not, let's say, overshooting too much. We keep the flash a little lower and then have it more or less, try to keep it more or less on the same level. This has two advantages. So the temperature of the flash tube is more or less constant, which means we do not have blue at the beginning and more red at the end. We have something like constant daylight during the entire discharging curve. And the other thing is we have the same amount of light. So not talking about color, but the amount of light that leaves. So we have like super short time continuous light. So it's like switching on, let's say, a LED or whatever. You switch it on and off after a 30,000th of a second or 10,000 or a 1,000th of a second. But during the flash, we have kind of continuous light. What is the big advantage of this? The big advantage is that we can use HSS. HSS is a technique that, in my eyes, is still to be used outdoors. Okay. It doesn't really make sense, in my eyes, to use HSS in the studio, because if you would like to freeze, to stop a motion in the studio, dancer, breaking glasses, whatever, the flash duration, I repeat myself, the flash duration is much shorter than the shutter speed of your camera. So you rather keep the shutter open during a 60th of a second and use a short flash duration of 20,000th of a second. This photograph will be sharper than if you use a normal flash and a shutter, the shortest possible shutter speed, let's say, I don't know, 8,000, 4,000 of a second. Okay, so when you're in the studio, use short flash durations and longer exposure times, or shutter speed, sorry, wrong word. Longer shutter speed, super short exposure time, meaning flash duration. HSS is only very important if you go outside. Let's say we go outside, sunny day, you would like to work with a large aperture to have the background out of focus, and you still would like to underexpose daylight. So what can you do, or what do you have to do? You have to work with extremely short shutter speed on the camera. But if you work with a short shutter speed on the camera, if you have a curtain shutter, you cannot use flash equipment because you always have a wrong exposure. You have these black bars somewhere in the picture. And if you choose on your camera, if you choose, let's say, a shutter speed of 8,000 of a second, this 8,000 of a second corresponds to 1 pixel only. Could be the first pixel, 1 pixel in the middle, or the last pixel, but we are only talking about the exposure time of 1 single pixel. But the entire exposure process from the first pixel all the way down to the last pixel still lasts about the 200th of a second, because we can't move the curtain much faster. So that's why if you want to work with short shutter speed and flash, we have to work with long flash duration. So HSS is nothing else than extending the flash duration, that we have a constant light from the very first pixel to the very last pixel. And that's why it is so important that we have a rectangular discharging curve. So the darker the model, the less ambient light you have on the model. Let's say the model is completely in the shadow. So you would see with the HS technology, you would see a certain fall off of the light intensity during the exposure process. So the first pixels will be brighter than the last pixels that are exposed. But if we have a short time continuous light, we have a very even exposure during this HSS exposure. Right. Data technical, I hope it was understandable. Right. Okay, good. So recycling time, as well, a very important parameter, because you would like to shoot a lot of pictures in no time. And there again, I would like to start with the situation in the Scoro power packs. There we have, at reduced power, this is very important, we have a recycling time of 0.02 seconds. So 200th of a second, or 50 flashes in 1 second. On the Satos, again, we have a different situation. We have a recycling time which is not even a real recycling time, because the recycling time, the shortest recycling time of 0.008 seconds is not really the time that we need to recharge capacitors. It's the time that we had to program into the power packs to let the flash tubes cool down, that the gas inside the flash tube deionizes again, that we can actually start flashing the next one. Otherwise, we would have an afterglow, and the capacitors would be emptied with more or less like a continuously light-emitting flash tube. But that's not what we want. We want to have one flash, second, third, fourth, and so on. So that's why we always had to disconnect this and wait this super short time of 0.008 seconds. Okay, so this is not a classic recycling time. So this is just the time to deionize the gas in the flash tubes. More or less, we have 50% of the full power of the power pack at our free disposal. Now, what does this mean? This means that this recycling time, this virtual recycling time of 0.008 seconds is more or less independent of the power, and that's crazy. Let's say we can have, if we have a large Satos with 3200 joules, half of it, 50%, would be 1600 joules. And this means that, for example, we can have 2 flashes of 800 joules, which is really a lot of light. And the time in between these 2 flashes of 800 joules is not shorter than 0.008 seconds. Imagine, that's crazy. Or if let's say I would like to have 10 flashes at the fastest possible. So I divide these 1600 joules by 10. The result is obviously 160 joules. I can have 160 joules every 0.008 seconds, and this 10 times. Okay, so that's why this recycling time is a super dynamic value. Yes, it depends on the power, but it depends as well on the amount of flashes you need. It depends on the duration. Do you need this during half a second or 10 seconds or just 2 flashes? So it's not one parameter that can be given that easily. So I think the easiest way to understand it, I call it like a salami tactique. So half of the salami is at your free disposal, and you can cut it in small pieces or in large pieces, but half of the salami, half of the charge of the capacitors is at your disposal. You can eat it as fast as you want with large chunks or with super small slices, but it's absolutely to your choice how you want to eat it or how you want to use your energy. Okay, and this is really a big game changer. Let's say you have an athlete, you have to shoot an athlete flying through the air. You get like, I don't know, 2 chances. Now, if you would like to shoot this with a lot of light, on earlier power packs, you had maybe 1 flash and that's it. So you have to press the button at the right moment. But now with the Satos, even at very high power, you can have a super fast sequence of maybe 3 exposures within 200ths of a second at even 600 or 800 joules, and that's really a game changer. That fast sequences do not always require super low power settings, and this helps. Right. Okay, so we talked about the salami, and this is just one of the examples we did a couple of weeks or months ago, playing around with the new Sony Alpha 9 Mark III. Here we have been shooting 24 frames in 1 second, somewhere around, I know that it was f-stop 11, so yeah, acceptable aperture. And I guess somewhere around 100 joules plus minus, but for sure no problems with this. And then we had to do this like 2 or 3 times only, and this is the original thumbnails that you see from Capture One, I think. Yes, exactly. So you see that somebody, I press the button, then I take a very fast sequence of photographs while a colleague drops the iPhone into the water, and then in the end I just have to choose from this sequence the best shot. I think we did this 2 or 3 times only. But we didn't have to throw the iPhone into the water like 10 times because every time it hit the stone, so it would not have been very nice for the display. So we had to do this 2 or 3 times, and then we actually got the perfect shot. So this is really a game changer and makes life somewhat easier in the studio. Right. So end of part 2. the technical data and features. There is a lot more, but if you are more interested into details, just go through the data sheets that you can download from the broncolor.swiss website. But I would like to have a quick look here now at the two questions that came in already. So the first question from Ali, 0.008 seconds achievable on battery. Yes, achievable from battery. It doesn't depend. If it's not, I tried to explain it a little bit, but obviously it was not clear. We are not really we are not depending on recycling. Also, number one, it recycles faster. The more batteries, the faster it recycles. That's number one. Second, if we talk about the 0.008 seconds, we are not even recycling. Okay, we have the full charge of the capacitors, and half of the charge we go it's our free disposal. Even if we don't have the time to recycle, we can use half of the battery of the capacitor's charge at any shortest possible interval, which is 0.008 seconds. So if it's connected to mains, or if you are shooting from battery, it's the same. We have a difference if we really start emptying the capacitors almost completely, and if we have to recycle them from battery or from the mains, then it makes a difference. But then, ironically, it's faster with batteries, and it's slower if you have power supply units inside the power packs. Because we are kind of limited by the amount of energy we pull out of the wall, but we designed the batteries ourselves, so we can pull more energy out of the battery. So that's why I guess it's probably the first power pack that reacts like this, that is actually faster. The more batteries you have in and the more power supplies, the slower it is, because we can get more energy out of the batteries than out of the electricity from the wall. Okay, second question, is continuous light mode, is it better to use on mains power? Continuous light from battery or from mains? If you have, yes, connected to the mains, because as I explained before, the power consumption or the energy consumption from continuous light is surprisingly high compared to flash. So the light quality is exactly the same. It's the LED, the light is adjustable exactly the same if you use batteries or mains, but of course the batteries are drained much faster if it's not connected to mains. So if you talk about really filming, taking video clips during quite some time indoors where you have the mains, yes, keep it connected in a way just to keep the battery charge on an acceptable level. But as I said, it's not better. It just lasts longer if it's of course getting the energy from the wall. But the quality of the light is obviously the same. Right. Okay, so question window again is empty, which means we dive into the last part. And there I would like to pick out a few special functions. But first, I would like to give you another quick look at press the right button, a quick look at the menu. All right, going somewhere down here. Now you can see my beauty dish reflecting in the screen. Still a little bit, focus there. Okay, good. So I go into the menu, which that's reflecting again. So here to the menu button, and I'm not going to discuss now all the functions. I just pick out a few of them. So we have alternate, delay, sequence, and flash settings. Flash settings, that's one of the functions I'm going actually to pick out. What you will not see here is something like interval. Interval is something that's always used in combination with a sequence. So that's why if I press sequence, I can change here the sequence to, let's say, 3, and down here I adjust the interval. So the functions that are always, let's say, together, they are grouped here as well. That makes more sense. We will discuss something similar here with the flash settings. Okay. We have in synchronization, we have the information about how we synchronize. RFS can be obviously on or off. Here it indicates the current studio channel. The cell sensitivity can be high or low, or the unit or the cell can be completely off. If we change here the studio channel, we do this here in the studio setup. So again, sync and studio setup, the things that have to do something with each other, just next to each other, that we are not getting lost in navigation. Modeling light, quite straightforward. However, there's one feature compared to the Scoro. We can choose the level of the modeling light. It can be low, proportional, or full. Or of course, I can switch it off as well. But additionally, I can choose the color temperature. It can be daylight balanced, 5500 Kelvin, or you see it a little bit on my finger. It can be tungsten, 2.8, or 5.5. So it's your choice. Sometimes there is a technical reason that you would like to have a daylight balanced. If you work with a little bit of daylight as well, you add a little bit of shutter dragging maybe, so you might want to have it daylight balanced. But me, for example, growing up with broncolor, I'm used that my modeling lights are tungsten balanced, and the daylight modeling light, sometimes I feel it, I think it's a little unpleasant. It's very cold atmosphere in the studio. So normally I prefer to have it tungsten balanced, but when I do techniques with shutter dragging, of course, then I change to daylight. But important is that the choice is yours. Wrong button. Okay, modeling light, lighting mode, that's as well something I will pick out later on. And down here we have, for example, reset. We can change the network. We have a precise, oh, sorry, thanks. Yeah, sorry. And thanks, Raman, for letting me know. Okay, so here further down we have power info, which is precise information about the batteries. Now having it connected here to mains, of course, we still are at 99%. And then I changed a little bit here on the sequence. So just to make sure that I don't make any nonsense, I go to reset, I make a basic reset, and then all the special functions are out again. But as I said, I would like to pick out only two functions because they are slightly different, and this is the flash settings, and I would like to talk about the lighting mode. Right, okay. So we have, before we talk about these functions, we have the standard functions where we start in the menu on the top, alternate, delay, sequence, and so on. So yes, sequence, interval, delay, alternate. These functions, we call them timing, and we can as well program them directly from the pulsar L lamp head, and there we group them again as to make the display or to make the menu shorter. We group them in a function called timing. And then we have color corrections. And the entire presentation today is about the differences between the Scoro and the Satos. Now, you know all these functions. You know sequence, interval, delay, alternate, color corrections. You know these already from the Scoro and from the Satos. But the big difference is in the next two words, it's a per channel thing on the Scoro. Sorry, it's a per channel thing on the Satos. It's a global thing on the Scoro. So I can only have all the lamps connected in a sequence on the Scoro. If I delay a Scoro, all the three lights connected to the power pack are delayed. If I want to alternate between two lights, let's say to create a free mask, I need a second Scoro, and I alternate between the two Scoros. If I would like to make a color correction on one of the lamps connected, I can do this on the Scoro, yes, but all the three lights will be changed in color. But most of the time, I have only, let's say, a color problem on one of the lamps connected, because maybe I use an indirect light, or I put a light through a diffuser, which is not 100% neutral in color, and maybe this diffuser is slightly warm, reddish, yellowish. So I can program on only one outlet per channel. On only one outlet, I can program a slightly cold light to compensate this. And that's working here in the studio super precisely. Let's say if I shoot advertising for these packs, they are all within gray values, black values, black aluminum and the black rubber protections. The handle is grayish. So all in neutral color values. And if I have just one light, which differs a little bit from the other ones, I have a big problem. If I have a colder light here than on the top, I can choose my gray balance wherever I want it. It's one of the two lights is always wrong. But if this one is a little bit too cold, I can simply program here a slightly warmer flash per channel. So that the color of each individual light can be adjusted super precisely. It's a super technical feature, but it's super important for precise photography in the studio. And it's much more precise than what I can do with CC filters. So it's a super convenient feature. Okay, so all the functions, sequence, interval, delay, alternate, and color corrections are available per channel. And that's really cool. Okay, the two functions I would like to point out. So the one, I name it here flash mode. In the menu, it's actually called flash settings on the top right. So I'm talking about flash settings. Here, my mistake, I name it flash mode. Again, I would like to start with the known situation from the Scoro. We have a menu point, which is called flash duration, or actually it's called tier 1. There I can program a tier 1 optimum. Tier 1 is actually the value for a flash duration, or I can choose a tier 1 minimum if I need a short flash duration. I can as well, in a different menu point, I can control the color temperature. And on a physical button, I can set the power pack to speed mode. The problem is that all these functions, they interfere. So on the Scoro, if I change, and on the Satos, it's the same actually. If I change the color temperature, it has influence on the flash duration. If I change the flash duration, it has an influence on the. If I change the flash duration, it has an influence on the color. Okay, so flash duration and color temperature, they are connected. They are coupled. They have a good time together. They can't be separated. You can't have a very short flash, and it should at the same time it should be very long. It's always short and bluish, long and reddish. That's always the same. So it could be that on a Scoro you program a short flash duration, and then you see, oh, the flash is a little bit bluish. Then you go further down in the menu and you correct the color temperature, and this goes back and has influence on your flash duration. So we didn't want to separate these values anymore. We didn't want to confuse you with speed and tier 1 minimum, tier 1 optimum, HSS, and so on, because it's always the same in a way. So that's why on the Satos, there's just one menu, which is here the flash settings. It starts here on optimum, and if I go further down, it becomes warmer, minus 100 Kelvin, minus 200 Kelvin, minus 300, and then HSS. So that's what I said, it first becomes warmer, it becomes more reddish, and if it's the longest possible, it's HSS. We need a long exposure, we need a long flash duration if it's HSS mode. If I go back, and you realize that it's a per channel thing, huh? You see this here very nicely, okay? So I go back to optimum. Now I get colder or shorter, it's the same, plus 300 Kelvin is nothing else than speed. I go even colder, plus 400, 500, 600, 700, 800, and then not 900. Now we reach the shortest possible. So we have a tier 1 minimum. But it's just, again, to make it more clearly, to make it more straightforward. We didn't want to have different functions that in a way interfere and influence each other. We just have one menu. How do you want to have the flash? Do you want to have HSS? Do you want to have it super short? Do you want to have absolute neutral color? So it's all the same. So that's why we packed all these into just one menu called, I forgot it again, called Flash Settings. Right. Okay, makes things a lot easier, makes things much easier to understand that it's always the same story. Right. Okay. The other thing I would like to pick out is the lighting mode. It can be flash or continuous. Again, I'm repeating myself, it's a per channel thing. And now for once, I'm not showing you the power packs, I'm showing you the lampades. If I dive here into the, not modeling light, but the lighting mode. So again, per channel, I can choose, is it flash or is it continuous light that I want to use? So let's leave outlet number 2 on continuous light, and let's have a look at the main menu. So again, I would like to make this a little darker, that you can see clearly what's happening to the colors. So if one of the lampades, it's in continuous light, it's clearly, very clearly indicated with a dominant green light. Why? Because this channel does not fire anymore. No matter what you do, if you define one of the outlets as continuous light, it's never going to flash even when you synchronize it correctly. And that's, in my eyes, this has to be communicated very clearly to you as a user. That's why all the power adjustment, the color balance, the green magenta shift is in a dominant green. That even if you press the button and it's not firing, that you're not, let's say, panicking and you go to the synchronization setting, RFS or the cell, that you know instantly, oh, of course, it's in continuous light, it's not allowed to flash. Very cool is that this can be, again, done per channel. So outlet number 2 is still, let's say, white because it's not active. If I press the button, it's green. And now if I change here the power, I'm only changing the power of my flash, while outlet number 2 is still in continuous light mode. In this situation, it's on 100%. I will talk about the power range right away. If we use the modeling light can be 2800 Kelvin or 5500 Kelvin, only these two, only tungsten or daylight. Now, I have here much more possibilities to adjust the light, from the color of the light, from 2800 Kelvin all the way up to 6800 Kelvin. Okay, so from warmer than tungsten to colder than daylight. And not only this, even the green magenta shift, let's take this back to daylight, which is about 5.5, 5.4, okay? And even the green magenta shift, I can adjust it. So I have now a shift towards green, or I can move as well this light toward magenta. So you are super, super flexible. If you are in continuous light mode, I would say that the pulsar L turns into a LED F90. Maybe some of you know the broncolor LED light, which is called LED F160. 160 corresponds to the power outlet. And if I replace the 160 by 90, so we have a LED F90, but with the same light quality regarding the free choice of color temperature and as well the green magenta shift. The lampade is focusable, so it's exactly the same freedom, the same possibility to create or to work with exactly the light that you need. Good. Right. And as I said, this can be done per channel. So let's have a look at this as a summary. So as I said, the pulsar L becomes in the end something like a LED F90. Of course, we have continuous light as well on the pulsar or on the uni lights, but of course, yeah, not really this continuous light luxury that you can change the color temperature, that you can change the green magenta shift, that you can actually switch off the flashes. That's all not there in the pulsar G or in the uni light. We just have the modeling lights. On the pulsar L, we have a clearly indicated green display that tells you very clearly that watch out, this channel is not going to fire even if synchronized properly. We have not 10 f-stops of power range like with the flash. We have, let's say, only 4 f-stops, but continuous light anyways, most of the time it's in full power anyway. So we have the possibility to change it from 90 watts, which is full power, all the way down to 6 watts. The color can be adjusted, not, I think it was steps of 50 Kelvin. Let me check quickly. Yes, in steps of plus minus 50 kelvins, all the way from 2800 Kelvin to 6800 Kelvin. And that's not enough. We can even adjust the green magenta shift of our light. So absolute control of our light in continuous light mode. One quick word about compatibility. Of course, Satos works best in combination, I can show it you here, in combination with the pulsar L lamphead. Okay, but maybe if you upgrade your system, maybe you don't want to upgrade it all at the same time. So which way do you or should you go? Should you go for the Satos first and maybe work with the old lampheads, or should you use your old power packs with the new lampheads? Working with Satos and pulsar G and Unilight is only limits you in very, very few situations. So let's say all the features of being able to adjust the color per channel, to work with alternate per channel, sequences per channel, the super short shutter speed, the pulsar G allows to do this. The extended power range, yes, pulsar G or the Unilight does it. Where's the limitation? The limitation is, of course, in continuous light mode. So the pulsar G will not have a daylight balanced modeling light. Okay, you cannot adjust the green magenta shift. And of course, no bidirectional communication, obviously. But all the quality that offers Satos Power Pack on the flash side is available with pulsar G, with the older G heads or the Unilights. So there are almost no limitations. Another limitation, old lampheads, new power pack, is the modeling light if you work with batteries only. If you have your Satos connected to mains, you can use the old lampheads, including Pico light, ring flash, all the fancy lights we have, and the modeling light works perfect. The flash works perfect. Okay, the modeling light is only off if you work with battery only. Okay, working with the old lamps with Satos in the studio has even one advantage, which means that the energy for the modeling light of the pulsar G head comes directly from the mains and does not go through the battery. So the modeling light of the old lamps is not draining the charge of the batteries. Okay, so your batteries basically will always be at full charge, even when you have the modeling lights on full power. Okay, so I don't really see any reason why you should not, let's say, choose this in-between situation if needed, and you can easily combine a Satos with all the lampheads. On the other hand, if you would like to work with the new lampheads, but you still want to work with your Scoros or even all the power packs, there you have a lot of limitations because, for example, you never have modeling light. A Scoro simply cannot feed a pulsar L because it has a different voltage. Of course, no bidirectional communication. I mean, and you don't have all the things we discussed right now from the Scoro. Of course, they are not based on the lampade. It's the power pack that makes all the difference. So having or going first with the new lampades and using the new lampades on all the power packs is not the best choice. Okay, if you want a step-by-step upgrade, new power pack first, old lampades, and then the lampades in the end follow. But obviously, it's clear if you change the system at the same time, of course, then you really have 100% of all the beautiful advantages. Right, so this was the word on compatibility. This just two pictures to illustrate what actually can be done with this continuous light mode. Like these photographs, they can be done now with just one Satos. The models are flashed with two lights in flash mode, and then the third light is in continuous light mode. On the left side, it would be continuous light mode daylight balance, which means the same color like my flashes. And on the right side, Deborah is jumping here as well in daylight balanced flashlight, but the continuous light is tungsten balanced. So that's why her hair and the skin, the dress as well, is of course much redder than in nature. Okay, so until now we used additional lamps like LEDs or even earlier HMIs to shoot stuff like this, and now it's all possible with just one power pack and in combination with the Pulso L light that goes with it. Okay, so before we go for a last round of questions, I would just like to summarize this quickly. So we have on the right side with the Scoros, we have the absolute workhorse. I work with these Scoros for many, many years in the studio. They never fail on me. They do pretty much everything I want. Very important to understand is that there is not really a light quality difference. The light balance, the CRI and so on, it's the same with a Scoro. There's no difference in light quality. But as we have seen before, some of the functions on the Scoro are just globally available, not per channel. And what could be interesting as well is that with the Scoro and with the Scoro E, we have a budget version that's available as well. What's the difference with the budget, the slightly less expensive version of the Scoro E? It has only 2 outlets. The minimum power is 2 f-stops higher, so not 3 joules, but 12 joules of minimum power, and it has a short menu, so you cannot program it that precisely like the Scoro S. Then we have, as a summary, the Satos. So every photographic feature, any challenge you can even think of, the Satos will solve this problem. Okay. It's, we like to say that it's actually designed for rentals because it's super heavy duty and it's one unit for every application. So you don't have to store a battery operated power pack for your location guys and you need another one for the still lifers. No, it's one unit. It's the Satos that is the best choice, the most controllable power pack regarding all the possible aspects in the studio, super precise, but as well the extremely powerful battery operated pack for, I don't know, the fashion guys, the action guys outside. It's one for everything. Super easy to use, self-explaining and extremely intuitive. So with the flat menu, you press the button, you arrive to the flat menu in several languages. Everything is directly accessible, so super self-explaining. And again, it's the most precise power pack in the world because we can correct and adjust the color per channel. Okay. So this just to summarize it. And now I would like to go through a last round of questions. At the moment, we have only one. So if you have any questions left, please type them in right now. So the question comes from Christian. Battery usually have a number of charge cycles that they can last. How does the 1+1 setup impact the life cycle as batteries will continuously be charged? Okay, It's the lifespan of batteries is generally calculated in charge cycles. Okay, which means if you discharge it to 50% and recharge it again, it's not how shall I say, it's just half a discharging cycle. What's important is that you do not, like all the batteries, that you do not discharge it completely. Okay, that let's say that you do not, let's say, make it empty, and then after it's empty, it's not still not completely empty. So if you make it empty and then you put it away and don't recharge it, then it can be a deep discharge, and this of course damages the battery. But the let's say if we talk about these high performance batteries that we use nowadays in power packs, in bicycles, in cars, in motorhomes, and so on and so on, the battery life is calculated on entire recycling circles. Okay, so if you discharge it to 50% twice and recharge them, it's like just one circle. Okay, and I'm not really 100% sure, but I would say that after something like 1,000 recycling circles, we still have, I would estimate, some 80% of the capacity. But don't take my word on this. But that's how we calculate this nowadays. If you're not happy with this answer, anyway, if you have a question later on, please just write a quick mail to support@broncolor.swiss, and then you will get a more reliable answer from our technical department. But actually, to give you a shorter answer, it's not a problem to have them constantly connected, because you discharge them to 90%, you charge them again to 100, 90, 100, so they are never really empty, and this would actually damage the battery. And of course, if you go 10 times to 90% and back to 100, this is nothing else than one full recycling cyclus. Okay, good. Right, okay. So the question window is empty. So just two more things, as I mentioned before. If something shows up, if you have another question later on, this evening, number one, best solution, contact your local dealer, broncolor distributor near you. They are all trained on this fantastic product. They will be able to answer your questions. If they're not able to, they will contact us again. Second option, write an email to support@broncolor.swiss. And finally, I would like to invite you as well to the next webinar, which happens on May 29th as well, here from the studio, completely different. I will talk about softboxes. Softboxes, in my eyes, kind of an underestimated light shaper. If you really understand how softboxes work, if you really understand their light characteristics, there's unbelievable potential in softboxes. And that's what we talk about here in about a little bit more than a month on May 29th. It's a Wednesday. Last but not least, when I end the session here, you will be redirected to a review. So please just give us 2 minutes of your time, answer the few questions that we want to ask you about today's webinar. This allows us to hopefully come back with better webinars in the future. The question window is still empty, which means I would like to thank you very much for your time, for your interest listening to me, to us about our products. Have a very good evening. All the best from Switzerland. Bye-bye. Ciao.